Hello. In the next three chapters, we're going into optimization. Chapter 12, which we're studying this week, is linear optimization. 13 is integer optimization. And 14 is nonlinear optimization. This is a lecture that's going to give a demonstration of how to use Excel to solve a linear optimization problem. So it's going to be a fairly simple maximization problem. And we're going to use a fictional company, Par Inc., which is a small manufacturer of golf equipment and supplies. In this case, management has decided to move into the market for medium and high-priced golf bags. Par's distributor has agreed to buy all the bags produced. So that's not an issue with us. So we have various operations we have to consider when we're doing a maximization. And one of the things is the constraints. And obviously there's going to be some operations involved in manufacturing a golf bag. Cutting and dyeing the material, sewing, finishing, and inspection and packaging. And each one of those operations cost a certain number of skilled labor hours to produce a bag that's either a deluxe bag or a standard bag. So our goal is to develop a mathematical model of the Par Inc. problem, their business problem, so we can determine the number of standard bags and the number of deluxe bags to produce to maximize total profit contribution. So we do that by modeling or problem formulation. And this is a process of translating the verbal statement of a problem into a mathematical statement or model. And the general guidelines are to understand the problem completely, describe our objective. In this case, it's to maximize profit. Describe our constraints. We only have a certain number of labor hours available for cutting and dyeing, for finishing, for packaging, and so on. So those are our constraints. We then define our decision variables, and often these are going to be quantities. And that's true in this case. The decision variables are, we must decide how many standard bags to produce and how many deluxe bags to produce. Then we write the objective function in terms of the decision variables, and then write the constants in terms of the decision variables as well. Let me transfer over to Excel, and then we can take a look at that. Okay, it looks like we're now recording on Excel. So here's our model. Let me show the formulas. So again, we have our operations, and these become our parameters: cutting and dyeing, sewing, finishing, and inspection and packaging. And they take a certain amount of time for each of the different types of products that we're producing. In this particular case study, it's a standard golf bag and a deluxe golf bag. So per bag, this is what it cost us to do in terms of hours to produce a bag, in terms of each one of the operations. 7/10 of an hour for standard, 1 hour for deluxe. 5/10 of an hour for sewing to produce a standard bag, 5/6 of an hour for a deluxe, and so on. And then we have our profit per bag. and the available hours for each labor category. So these become our constraints. Our decision variables are in the gray cells, and they are the number of standard bags produced and the number of deluxe bags produced. We'll use the sum product function to get our profit. And in this, we multiply the number of bags produced for standard and deluxe, which is B14 and C14. And we multiply those by the profit per bag we get for each type, B9 and C9. And the result of that sum product is going to give us the profit, the total profit we have for producing the bags we have indicated. So currently I've only put a 1 for a standard bag and 1 for deluxe bag as placeholders. Next, let's look at our constraints. So for cutting and dyeing, we're again going to use our decision variables. These are B14 and C14, the number of standard and deluxe bags that we produce. In this case, though, we're going to be multiplying by the number of hours for each type of operation. So for our cutting and dyeing constraint, we're going to multiply our decision variables B14 and C14 times B5 and C5. In other words, the number of hours in cutting and dyeing to produce each of those types of bags. And that'll give us the hours used for the, the number, the quantities we've defined for each bag. Our hours available are going to be equal, in this case, to D5, which is just referring back to the 630 hours. It's often convenient to put our constraints in a central location and then refer to them in other parts of the spreadsheet. That way, we only have to change them in the one location. For the other constraints, we do the same thing. We multiply the decision variables times the hours for that particular operation: sewing, finishing, and inspection and packaging. So let's go back to our normal view. So with a placeholder of 1 standard bag and 1 deluxe bag, we have a total profit of $19. $10 from the standard bag and $9 from the deluxe. Let's take a look at how we set up Solver to help us determine the optimal amounts. First thing we do is set our objective function. In this case, it's B16, the cell that has our total profit formula. We're going to maximize that. We have other options. One of the more common other options we'll use is minimize. We might want to minimize transportation costs, for example. We're going to accomplish this maximization by changing our decision variables. In this case, B14 and C14, the number of standard bags and deluxe bags that we produce. We're going to do that subject to certain constraints. And our constraints are the hours used in total for cutting and dyeing must be less than 630. The hours we use in sewing, less than 600, and so on. So the hours used are in cells B19 through B22. They must be less than the limits, which are in cells C19 through C22. So we can put in an add, and then we put in the cell range that we're interested in, the relational operator, and then the limits for that particular constraint. When we've done that, we come down and we select our algorithm. In this case, we'll use the simplex algorithm. Once that's accomplished, we can click Solve. And Solver will come back and it tells us it did find a solution and it satisfied all the constraints. So in this particular case, given the constraints that we have, our total profit possible, let me do this again. Our total profit possible is $7,668. And we get that amount by producing 540 standard bags and 252 deluxe bags. And we notice that in fact, we are within the limits we have for the available labor hours. We have a lot of slack time for sewing, a little slack time for inspection and packaging. All right, thank you.